There we go. I'm pretty sure that's one of Dr. Siewert's students. Okay, I'll leave them in the waiting room. All right, so I'm really excited today. I was going to do something totally different, and then Dr. Siewert said that he could give a guest lecture about some of the technology that we're going to use out at the beef unit pastures at the farm. And he is going to give you a little bit of his background and some of the folks that he's working with in South Africa, where they're using like satellite imagery to identify elephants in like on in savannas and on rangeland in South Africa for management purposes. And so they want to kind of morph this technology into using it with cattle. And it would be really, really nice to use satellite imagery because right now, the way that we track animals using GIS is the real-time implications of that are super expensive. So I'm excited for them to be here. All right, before we get going and before I let them into class, I just want to make sure that we are on the same page about what it's due this week. So let me just switch. I'll share my screen. We'll look at Blackboard, make sure everybody's on the same page. All right, so we are in week 6. And if you were with us on Monday, we kind of went through what is coming up this week. And so just as a quick reminder, we've got a series of lectures and note guides about plant stuff. So not only range plant types, but the morphology, which for those of you guys that are on the animal science side of things, that's essentially anatomy. And then you'll also see a couple of lectures about range plant physiology as well. And that's where things get really, really intense as far as management, is how different plants actually perform differently in different environments and stuff. And so, and then, so you have 2 things due today, or not today, Friday by end of day. So the first is the quiz about the plant stuff. And then the second is a guest speaker assignment. And so that assignment is linked in here on this, on the week 6 Blackboard page. And so that is due for you guys that are in 394. And I'll just let you guys know, I've got a few people that are going to be extra that aren't going to be in class today. So part of Dr. Siewert's class may be jumping in with us, and then and some of the folks doing research with him, and then part of the beef unit crew as well. So I just wanted to get our housekeeping out of the way. Do you guys have any questions about due dates and stuff? All right, fantastic. Okay, so here is my plea with you guys. I'm fine with you guys not having cameras on if it's me, but because we have a guest speaker, if you guys are in a position to put your cameras on, would you please do so? It makes it a little bit more interactive. Thank you so much in advance. There we go. Hi, Sam. How are you today?
Doing good. Sorry, I had to find the unmute button.
I know you think we would be trained by now, but we're not.
I'm not used to being a student. I mean, being in the audience. Used to the podium now.
Yeah. So, well, thank you so much for being here. I am ready to turn it over to you. I just had a couple of quick announcements and we got through them really quickly. And I have bribed these guys to turn their video cameras on, which we appreciate. Thank you guys. But so this is my Animal Science 394 class, which is a livestock grazing ecology. Okay. And so we learn about every aspect of managing rangeland using animals. And so technology is a big part of that. So we're excited that you're here today. Thank you so much for doing this.
Sure. Well, thank you for having me. I appreciate it. And I'm glad to present to an audience like this. So I think I've got an interesting story to tell. So I will tell the story of how elephants and rhinos relate to cows and bulls.
Awesome.
Yep.
That's great. And you should have capability to share screen, and just let me know if you need anything else from me on my end.
Okay. I think you're seeing the presentation now.
Yep, we are.
Okay, great. So students and I came up with this name Saturday because we realized we needed a name. So it's still a penciled in name for the group here at CSU Chico, which is comprised of undergraduate and graduate students in computer science mostly, but also has participation from two other universities, University of Colorado Boulder and Embry-Riddle Aeronautical University in Arizona. And I'll explain how that all came to be. So we're thinking of calling the Chico portion of that group CREST, Chico Research for Environmental Science and Technology, which is a pretty broad name.
Yeah, I like it.
Okay. And the picture seemed to fit. So, yeah. And it's local. And we're hoping to capture your imagination here in the CSU farm and the beef unit in particular, and how you might get involved, how we might work together and do some research. And so how this got started, it's kind of an interesting story. I'm from Northern California originally. So for me, this is kind of coming home. I'm from the East Bay originally, and I've been gone 30 years. And I've been living in Colorado, Alaska, and Arizona before coming to Chico. And when I was in Arizona, I got the classic, email from the dean. Can you come down to the front visitor center? We've got some people here who, are interested in potentially sponsoring some research, which always gets your attention. And so I went down there, and it was individuals from SAP. SAP is a software company that essentially is a lot like Oracle, closer to home here, but in Germany. And they take a good portion of their revenues, somewhere in the neighborhood of 1%, to contribute to research for sustainability. So they basically were saying, we have money and we think you might be able to help us do something with it, kind of to make it simple. And they also had in attendance some members from the Elephant Rhino People NGO, which explained that they have challenges in South Africa they wanted help with. And they particularly they are teaming with SAP to send student faculty groups to South Africa, undergraduate and graduate, doesn't matter what your level is, but to see what we can bring to the challenge of deconflicting elephants, rhinos, and people. And I'll explain what I mean by deconflicting as we go through this. So we now have 3 universities involved. Some of that's my fault because I've been at all 3 of these universities. I have a research appointment at Embry-Riddle, and I'm on the graduate faculty at CU Boulder as an adjunct, and I teach there in summers in a graduate program that I started there. So that's my connection. And we have students from all 3 universities meeting every Thursday night at 5:30. So anyone who's interested is welcome to join us. There's no commitment or anything. You can just watch and see if you want to get involved with us. And we would love to have some scientists from your college. Okay. And so why should we do this, right? So that's the first question. Just because there's money available doesn't mean you should accept the challenge to do something. In fact, that was the first reaction we had. One of my colleagues at Embry-Riddle, we talked about it, and we're like, well, if we go to South Africa, what are we going to do, right? We didn't even really honestly understand the problem that well at first. You can imagine it. There's probably issues with elephants, rhinos, and people. Sure. But you don't really, if you don't have the background in it, I'm sure it's just like cattle ranching. What are some of the issues? And if you're not involved in it, you don't really know the details. So, but we had capabilities, which is one of the reasons we got called down to the office. So we've been working on, or I've been working on, and the group I have has been working on sensor system and information fusion for about 9 years. I got into it through my PhD studies and work with the Jet Propulsion Lab as early as 1992, arguably. But so I've been working on it a long time. And sensor system information fusion is kind of this magic thing where you take artificial intelligence, machine learning, and sensors, and you put them in a blender, and out of it comes hopefully more knowledge and more information than you would have had from any one of them alone. And so it really is kind of what the name implies. And the challenge, of course, we categorize the elephant rhino people problem as an environmental resource sustainability problem. You could think of it as a policing problem or a crime issue with poaching, but we're taking the approach, and we believe it is more, and I think ERP NGO does as well, that it's more of a sustainability issue, right? But we'd love to have your input too on that, because we're more the T and E in STEM rather than the S. So, that's why we're looking for help. So, and we think it's a great idea, or at least I thought it was a great idea when I joined CSU, to apply this STEM kind of capabilities to agriculture. You've already got the science, but bringing some of the T and E to it. And that's because basically it fits the mission of the university, right? To put it simply. And there's an educational component, strong educational component of bringing STEM to agriculture, and it's interdisciplinary, which is great. It's always great to get scientists working with engineers and technologists. And we looked at the CSU strategic plan, and it's a direct fit. So I guess that's the final argument. So we believe we'll have the blessing of administration and things like that moving forward with this. So that's why we want to do this. So this is more now details. So when I was driving into CSU for one of our student meetings, I heard on the radio about this Oxford University study where they were detecting and counting elephants from space. And that caught my attention. The obvious connection is, hey, we were asked recently to work on this elephant rhino people project before I left Embry-Riddle. And I had only left Embry-Riddle 3 months before I heard this on the radio. So I was like, we ought to be able to do that. If Oxford can do that, why can't we do that? And so I started down that path. So the first problem is getting the satellite images, because you're typically not going to find elephants on Google Earth. You can look, but you won't find them for a number of reasons. You need, I guess, real satellite images, for lack of a better explanation. One's from satellites where I can get satellite images tomorrow, today, yesterday, 3 years ago, a year in the future, on any given day, where I know it's going to pass over the exact area of interest that I want, like the CSU farm or Madikwe Game Preserve or Reedfleet Game Preserve. And so this just shows you that, yes, in fact, you can do this. This is, we believe, a bull elephant here. I won't say that I know it's a bull elephant, because honestly, I identified it and I'm not a biologist. But it sure looks like an elephant to me because I see the trunk and the legs. And we know there are elephants present in this reserve. We are in contact with the game reserve, and they do have some collared animals. And like you, they know where their animals are and how many they have. They might not know, their information might not be as good as the farm though, right? And actually knowing where your animals are all the time is probably something that nobody knows, right?
Correct.
Okay, so I wasn't sure, unless they're collared and you're just constantly tracking them. We'll get back to that. So we also wanted to see, can we see your animals down at the farm? And we can. So that got us excited. We did that just this summer. And what's really cool is we will hopefully be the third university to be doing this on Earth. So Oxford being the first, UC Santa Barbara being second. And as far as we can tell from research, this is the third university to start doing this, right? So it's kind of a new trend. It's a little edgy. You can see these animals with Worldview 3. If Worldview 4 was still working, we could see them better. But the thought is there's going to be a Worldview 5 and there's going to be other competitors. So this is just going to get better and better, right? So if we can see these animals now, we'll be able to get even better images of them from satellites, a few years from now, 5, 10 years from now. So if we develop the technology now, we'll get the data, right, in the future. And so the general principles of sensor systems and information fusion, I'm assuming it's probably new to most of you, but maybe not, is that you get better information when you combine data from instruments that are spatial. So satellites give you a lot of spatial information. You can cover 25 kilometers squared is kind of like the minimum, right? And to give you some perspective in our area, that's from O'Connell Engineering to the farm on a diagonal. And I would bring up the whole image, but it's
Gonna crash our system.
yeah, well, I don't want to risk it right now, but I'm glad to show anyone who wants to come by. And so it's basically around 16 gigabyte image and 4 gigapixel color image and so forth. And you're seeing snapshots, what you call a region of interest, a much smaller portion of an area of interest. And it covers every location on Earth except for the poles every day and makes 3 passes, generally speaking. So they're in what's called a sun synchronous orbit without getting too deep into it, which means they're just constantly imaging the Earth except for a small portion on each pole every day. And our group over the last 9 years, since I've been in academia working with students, has developed a lot of expertise with radar, LiDAR, time of flight cameras, long wave infrared, near infrared, et cetera. All these kind of instruments, which you typically find on satellites, we know how to make them work in the field, on the ground, or on things like aircraft or UAVs. And that was one reason that the ERP and SAP were interested in this. They had heard about this, or our dean told them about it. And what we imagine, our vision for this is that we should be able to make a cloud-based information fusion dashboard. So all of you should be able to go to a web page for the farm and be able to get all sorts of well-organized information on what's going on, or maybe where you range cattle, maybe even open range, right? And answer basic questions like, are there any issues? Are there any safety issues? Are there wild animals interacting with your domestic animals, et cetera? What's going on? The UC Santa Barbara study is in Point Reyes National Seashore, and they're trying to answer questions about elk and cattle interaction.
Yep. Big issues with Point Reyes. So yeah, that's great.
And so that's the other university working on this that we know of. And they're more driven, I believe, by biological science group rather than engineering. But we want to work with you guys if you're interested, so that it's driven by both perspectives. And one of the other things we can do on the technology and engineering side is what we call edge machine learning. So why this is interesting is you can put a whole bunch of instruments, cameras, et cetera, out there at the farm, and you could just stream data back to our offices. There's a big problem with that. One, you'll get tired of looking at it. It's a lot like looking at a security camera from 7-Eleven. Nobody cares unless something bad happened at 7-Eleven, right? And then the other aspect is you got to store all that information somewhere. So what you really want is a dashboard where when something interesting happens, you're alerted to it, or you can see it in a log of events that day. I got my start in this, really the SSIF in Alaska. We actually put a proposal like this together, and we won a $5 million grant.
Oh.
Which University of Alaska is very comparable to CSU Chico. I noticed that recently. So in all that size, number of students, size, kind of a lot of aspects are the same. And both universities have are near a lot of natural resources, a lot of interesting animals and nature around. And so you never know, right? And I worked with the Coast Guard, and I started doing SSIF field research with moose and moose on roadways and ports, bears in port areas, and all sorts of interesting things. Illegal fishing, so poaching, but yeah, in Alaska sometimes involves people from North Korea. So there's all kinds of,
Oh,
yeah, pretty
okay,
charged.
so that
scenarios.
became a safety issue.
Yes. So in fact, I even asked the Coast Guard, what do we do if we really get into trouble? They're like, call the rest of the military. They are the military, of course, but all the other branches. So the whole idea, one of the things I learned from the Coast Guard is it's a huge area, right? In Alaska, they cover the Chukchi Sea and the Barrow Sea, two giant seas, and the Arctic Ocean. Yeah, that's their area that they patrol. And so they want to focus attention where there are problems that are going to happen or have happened. They want to deconflict things before they happen. So they, want to know if there's a certain type of grizzly bear called an ice bear. An ice bear is a grizzly bear that's wakes up hungry early, and they're usually near the end of their life, and they'll eat anything they see. So if you have an ice bear in Alaska, it needs to be put down. There's no question. No one would question that. And so you want to deconflict before it happens, right? Provide domain awareness is the fancy term for it. This has traditionally been something that the military does. The military does this now. But the interesting thing is this can be applied to things like Alaska or Northern California or South Africa for really what are more environmental and sustainability challenges. That's the observation. And that has been the interest in Alaska. In fact, the link to ADAC should be in here, and you can go take a look at that if you're interested in that. And then I actually worked on a similar funded project at Embry-Riddle, smaller funding, that was to look at deconflicting drones with aircraft. And there's also a problem with birds and aircraft. So the three things that don't go well together are drones, birds, and aircraft. Yeah. And in fact, at Embry-Riddle, Arizona, we have a student pilot flight line. So students learning to fly migratory birds and students learning to build and fly drones.
Whoa.
So three hazards. And we worked closely with our campus safety security. And in fact, they were pretty appreciative of the research we were doing. We, however, didn't have anything to solve their problem. We were doing research. We did make recommendations, though, for systems that they use now. And so this idea of deconfliction, we believe, can apply to domestic and wild animals and people where there could be interactions that aren't ideal. Some that I've been made aware of are more local. So you might ask yourself, what elephants and rhinos matter to Northern California? Well, according to one of our students, who's from Eastern Oregon, who lives in a rural area with ranches, she has told me and verified with the Bureau of Land Management there are significant issues with range cattle and feeding in the winter and elk and poaching of elk. And the thing that I find interesting that I wasn't necessarily aware of is when I first thought of poachers, I thought of basically criminals. And that they must be doing it for the money, right? And what I've learned is that poaching has many scenarios, some of which include these elk are eating the food that I put out for my cattle. So that's why I'm going to shoot an elk. And yeah, I might get elk steak as a side effect, right? So there's kind of two things in it for me. Well, that same argument is true in South Africa, but it's perhaps stronger. If you imagine an elephant trampling your farm in South Africa, you've lost your entire crop. And maybe they did it because you were between their water and their food source, right? And they're dangerous, like moose. And now you've lost your income. And if you shoot the elephant, you can sell the ivory and you no longer have an elephant problem. So that kind of puts poaching in perspective for me. It's really, I think, deconfliction is probably an important aspect. And you could always build a fence, but these game preserves are huge. It'd be like putting a fence around Lassen Peak National Park, right? Yeah. So it kind of doesn't make sense, and it would be at great cost. So part of our hypothesis is that the satellite images will help. They have resolution down to 30 centimeters per pixel. That's sufficient to see elephants, rhinos, bulls, cows, elk, I don't have evidence for moose, but I suspect it would be true if you can see elk. There are images of caribou in northern Canada that people have collected from Worldview 3. So as I said, the issues with poaching, we're not necessarily trying to solve that. We're trying to bring information to the problem with the hope that it will deconflict the problem. And it could enable people who live in these areas as with local citizen science. So in South Africa, one of our ideas is to leave some of the computing equipment behind and the sensors so we can stay in contact with them and understand the problems better and enable or equip them. And the final point in the Oxford paper, which caught my attention, was the last thing they said is, well, we've got some compelling evidence, but we did a lousy job at ground truth. Somebody needs to do ground truth. And if you look at the UC Santa Barbara paper, I don't know, they may have done a better job at ground truth. I got to admit, I didn't understand it all because a lot of it was more in the biology area. But this seems like a real opportunity for CSU in particular, because we've got the farm. We should be able to do a good job of ground truth, certainly better than the Oxford paper did. And we can get information from the South African game parks, but I don't think their information will be ever quite as accurate. So my hope is that we can help the farm somehow. I don't know how exactly, but we can help you collect information for sure. And at the same time, the farm can be used to essentially practice what we want to do in South Africa. And then my hope is that it's valuable to both locations in the long run. Exactly how, we don't know. I guess this is research.
Yeah.
But we're hoping you guys have some thoughts and ideas too. So what kind of sensors do we have? So we had a little bit of luck. One of the new faculty after I left Embry-Riddle was from South Africa. So I got another call after I heard about the Oxford paper on the radio from my old dean saying, can you work with Dr. Johan Dorfling on this project because they still want to fund this? And I thought about it and I'm like, well, if I could find the component that fits with CSU in my new home, yeah. And so Dorfling and I put together some basic ideas working with another former colleague of mine. And what we came up with is, well, you can put fence, but if you're going to put fence in, it should be a smart fence with sensors on it. And you're probably never going to fence the whole thing. But that's one position. There actually are game parks that are completely fenced that exist. And you can go read papers about how effective it is and that kind of thing. And then the second thing is, let's assume there isn't a fence, or let's assume there's already a problem inside the fence, because the fence also presumes all your problems are outside the fence. And if you keep all your problems out, you won't have a problem inside the fence. Well, one of the things we know from computer security is you should assume that you've got a problem inside already, as well as one outside. So we want to put sensors inside in a mesh network. We like to be able to collar animals. So we've been looking into collars. So we have, I guess, physical truth, GPS tracking truth. And then we'd like to put camera traps, acoustic sensors, and seismic sensors inside, around the fence or inside. And at the farm, it could definitely be outside of the pastures so that it's less trouble for you guys. So, but in South Africa, it would be inside the game park as well as around the exterior. And a geophone is a really interesting instrument that has a lot of value to this area. It's a seismic sensor. I've got 3 of them. I'd like to put one at the farm in what I call phase 2, but we'll discuss that. It means digging a hole in the ground somewhere at the farm and dropping this thing in the hole and connecting it to a network, either if there's campus infrastructure out there or one where an ad hoc one where you can come and get data from it. We presently don't have such a sensor in this area. I looked, the closest one is I-5 west of Colusa. So we have a chance to make a little bit of history here. There's an international network of these sensors. And it seems like this is another one of those things, like we should have one of these.
We should have one.
Join the network. So we've got the instrument now. so it's also useful, obviously, for anywhere area that has active or dormant volcanoes or earthquakes. Our student at University of Colorado who was really interested in this, and I brought up the idea and he immediately lit up. He's from St. Lucia,
Oh
which
my
is an
gosh.
island that's basically a volcano with lots of
Yeah.
earthquakes. And he's like, well, I've been doing research on this for a long time. I'll help you guys. And so that's one of the sensors we want to place. They have been used with elephants. So elephants communicate through ground stomping, and that's known. But exactly how useful this is to know what's going on with elephants remains to be determined. There have been studies done. So you can definitely detect seismic activity from elephants. To give you an idea, seismic activity is 20 hertz and lower frequency. Humans hear between 20 hertz and 20 kilohertz. So you call that low frequency sound range or seismic range infrasound. So at some point it goes from seismic or vibration kind of oscillations that cause pressure waves to infrasound to sound. And then beyond that, it becomes ultrasound, which many of us are familiar with. So we're interested in seismic, infrasound, and acoustic, and what we can learn about animals from those instruments. We did this before for aircraft and drones, and it was probably our biggest success story.
Really?
So
Wow.
a lot of people were interested. And it's just, to me, it's kind of the classic, I hear it, I see it. We do that as humans all the time. I hear a noise, what is it? And then you look at it, right?
Yeah.
And so we're very interested in that. And these can be perimeter or interior. We're interested if we can help or learn from you what you do as far as tracking colors. We have experience with high precision GPS like RTK GPS, which is accurate down to, I think, centimeters. I'm not the expert on it, but one of my colleagues is. We have a $50 collar that you can connect through IoT and track animals for, I believe it's $2 to $4 a month. Continuous tracking on like a mobile phone. I don't know if it's something we could test at the farm, but I'm just throwing that out because I think it's a pretty low cost collar, and the data streaming is pretty cost effective too. And my understanding is that collars have been used at the farm already. And it seems like it's a technology area that, has kind of gone commercial. Like it's probably not a research area, but how you use them is probably a research area.
Yep.
And so I don't know how much time I have, so I can go through some of these more quickly. We know how to do drones. I'm not sure that that's appropriate here, but I'm just pointing it out. The response from South Africa was, we already do drones. If we want any help with drones, it'll be with the instruments on the drones, not the drones themselves. So as a group, we know how to build instruments for drones, if that's helpful, or aircraft, because of the Embry-Riddle involvement. And then we are taking the satellite images we have now. We have 3 sets. So we have one of the CSU farm area. We have one of Wheatley, one of Madikwe, and we're using MATLAB now to do quick machine learning to automatically detect and count animals. The theory is if you started getting these every day, you don't want to do this by hand.
Right.
And then the other thing is, could you actually classify? So could you distinguish bull from cow, bull elephant from cow elephant, et cetera? Looking at the images with the elephants, I believe you can. I believe I've seen a cow elephant with calf, but I'd want a second opinion on that before I go out on a limb and say that's what it is. But and that's where having some collaboration would really help. And we got people in South Africa too, because I know you guys probably don't work with elephants regularly, but this is definitely an interdisciplinary problem, right? You need lots of people looking at this stuff. And so you've got human truth, people looking at these images saying, yes, that's an elephant. Yes, that's a bull. And then you've got GPS truth. So you had a collar on an animal. So as long as the collar didn't fall off, you knew where they were. So those are the 2 types of ground truth we're interested in. And So here's the current student team as of a couple weeks ago. Embry-Riddle, CU Boulder, and CSU undergrad and graduate students are involved. This isn't everyone. There's more people. This is just who was on Zoom that night. It's always hard to get everyone there for a group picture. But we are an open research group, so we'd love to have participation from any CSU student or faculty member. And hopefully I've done a decent job of describing what we're pursuing. Just to give you a little bit on my background, I've been doing this since about 1992 was when I went to graduate school and started working with the Jet Propulsion Lab. And then, I worked on space telescopes and deep space probes. And when I started teaching at first part-time, I was working at Intel and corporations like that, and then teaching at night. I wanted to bring the magic of instrumentation into the classroom. So I started bringing long wave infrared cameras and things like that to robotics and having students build projects with them. That kind of turned into me eventually defecting to academia full-time, worked on the Arctic project I talked about, the drones and aircraft project at Embry-Riddle, and then ERP. In Alaska, I spent a lot of time with a lot of animals, some of them pretty dangerous. The most dangerous animal in Alaska is a moose. The second is the black bear, and the third is the grizzly. So most people would pick the grizzly. But as far as fatalities and injuries, I believe that's the current order. So moose are the biggest problem, which is interesting. And so I did a lot of work with moose. This is probably too close to a moose, but you don't always get to choose when you encounter a moose in Anchorage. So my research was a constant thing going from my door to the school. This is actually, at the University of Alaska, this is the path to the parking lot.
Oh,
so,
wow.
Yeah. So, and my understanding of moose is this was not a problem, but I needed to keep my distance. The animal's in a posture where she's not threatened by me. She just doesn't care that I'm there. She probably doesn't have calves in the area. And you can tell that by ear position and body posture and all those kind of things. And so we played around with, can we take machine vision and computers, skeletonize a moose so we can better detect what its behavior indicates and things like that. Mm-hmm. There's 1,000 moose in round numbers and 1,000 people killed by moose in Anchorage every year.
Wow.
Mostly auto accidents, but some of them on bike paths and walkways and things like that. When it's on a walkway, the moose wins.
Yeah.
You get
every time.
Yeah, they go like this and you go flying through the air, and that's the last thing you remember from what otherwise they seem quite friendly. So that I've been interested in this for a while, and the Alaska experience really got me interested. So I think there's a lot of environmental things you can do with sensor system and information fusion. Other things we looked at, I don't know if I mentioned this word, bears at ports and things like that. So where do you guys come in? Well, we think we could help monitor, track, classify, identify with machine vision with the satellite images. They're gigapixel areas of interest. They have color, they have NIR, which might be more interesting to you. So you can determine things about vegetation. They don't have long wave. Long wave, in my experience, is how you find out the most about soil moisture, but they have NIR. So they have 8 bands, 3 of them, the standard kind of visible color bands, and 5 in the NIR. They have geolocation information. So when you see something in the image, you can also determine its latitude, longitude, altitude, exactly where it is. And like I said, Oxford is doing this and UCSB is doing this. So I think we have a couple chances to kind of make a mark, one with the seismic sensor, putting it on the network, and then being the third university to be actively pursuing this.
Yeah.
We have a paper that we're giving in January that's on the technology, but we're open to collaborating on future research and papers and things like that, once we get further along. And as I said, we wanted to use our location as practice for South Africa. That's how it started. But as I started talking to Casey, I realized, well, there's things going on right here, right? and the animals maybe aren't the same size. A bull elephant's 24 feet long, full size one. But, I looked up bulls and I'm like, well, they can be as much as 2,300 pounds.
They can get big.
Yeah, so that's getting close. And I've heard a little bit about, open range and possible conflicts with wild animals and things. So that got me more interested. So our thought is phase one's real simple. What we want to do is just place some camera traps, and I actually have them right here with locks and straps, and you just put it on a fence post and lock it down.
Cool.
And leave it, and everyone's seen these. These are off the shelf. It's a starting point.
Yeah.
We get better cameras, but our first step is getting the data as quick as possible from the research perspective. The second thing we have are microphones, and I have a picture of this on the slide. We have quite a good range of microphones, from measurement microphones, omnis, cardioid, et cetera, all kinds of smart microphones. And we also have the seismic sensors. So for phase one, we just want to put the camera traps because those are easy. We figured they can just go on a fence post in like 3 different areas. We'd like to take an acoustic background survey, which basically means me or a student walking around with a tablet and microphones and just collecting acoustics as a starting point, not leaving them there yet. We could do that in a follow-on phase, but just kind of to characterize it. Because part of sensor system information fusion is you kind of need the data to figure out what you can do with it.
Right.
And then we have the satellite imagery. So that completes phase one. Those are really the only goals we have for the fall.
Cool.
And then we want to finish our paper, but we want to talk about phase 2 and phase 3. And that, ideas, these are idea stage only, but we have the geophone. We would like to put that in the ground somewhere. The farm seems like the best choice to us, honestly. Other locations could be like Big Chico Ecological Reserve.
Mm-hmm.
But I think at the farm, you'd have the possibility of figuring out what goes on, especially with the larger animals, if there's any kind of ground stomping they do, or I don't know if they do anything like elephants, but
They come after the beef unit crew when they know they're gonna get moved to a new pasture, and it's a significant sound.
Yeah. So that would be fascinating. I think, anything like that data we can collect. It's kind of like when we set out to do this at Embry-Riddle, we just figured we'd see drones and aircraft. We saw all kinds of fascinating bugs, birds of prey, bats, bugs we didn't know existed in Arizona.
Wow.
We actually got the biology group excited and radar people excited, because to radar people, birds and bugs are a problem. To biologists, birds and bugs are cool things to study.
Our life.
Yeah, we had them imaged in infrared, and they're like, we want to see them.
Yeah.
So, so you kind of almost don't know what's going to happen. That's been, I don't even try to predict it.
Right.
So, you can say, well, it's probably going to be interesting if I get an infrared camera out there or whatever instrument it is. And then maybe I can combine the instrument data to know more than I would from the single instrument. And so the long term would be if there could actually just be things left there permanently. We did that at Embry-Riddle. We wound up installing, getting a grant and installing a radar so the campus can detect and track birds and drones flying over campus, which actually is kind of important to them because they have student pilots flying over campus. It's in Class D airspace because there's an airport essentially on campus. And then we also installed an all-sky camera, which you can use for all sorts of things, that collects images of the entire sky above the engineering building, 120 megapixels, 30 times a second. But that's where the machine learning comes in, because nobody's got to look at that. You got to have automation. So I don't know, that might be a good place to wrap up. These are just pictures of instruments I have ready to go for phase 1. This shows how you do the machine learning. Actually, you don't have to be computer scientists to do this. Anyone can get MATLAB at CSU and you don't need to write any code. You can just start labeling targets of interest, and then it has a GUI for the machine learning.
Ooh.
And so, definitely it's not something that's only open to computer scientists. It's open to anyone.
Yeah, that's, you know what, Sam, I'm glad you said that, because we're going to do, for this class, we're going to write a grazing management plan for a location in Shasta County. And usually, just because of my technological skills and time, we usually just use Google Earth to create our images and stuff and capture them that way. And but MATLAB might be a really good piece of technology to use in the future too. So I forgot all about MATLAB. So
yeah, it definitely it's a programming environment, but they've gone more and more to a user environment where they have tools.
yeah.
And honestly, like their camera calibration, I used to do it the hard way. And once I saw their GUI for camera calibration, that's all I use. Right. So, when you need to know, like take the distortion out of a camera image, they just automatically figure it out by you showing the camera chessboards over and over at different angles.
Yeah.
So they can do some pretty amazing things. So we use MATLAB a lot, and that opens it up to all disciplines, I think, as far as the software aspects. And we usually start there because we don't want to develop a bunch of code that's the wrong thing. Right. And yeah, and you can they have all these machine learning algorithms here that are pretty well known. And we believe it's probably possible to classify as well as detect and count. Mm-hmm. Probably not possible to identify or recognize with the satellite images, but certainly possible to identify and recognize with the camera traps. Yeah. Right. And then that's a classic sensor fusion. I saw it from space and I saw it with the camera trap. And so I know who you are and where you were. Right. Yeah. So that's a good example of sensor fusion. So the hypothesis is that the satellite images, the big value of them is they're spatially superior. You can cover the whole farm. We can look for bulls and cows all the way between O'Connell and the farm. So I suspect once we train it on the farm, we'll find bulls and cows in other adjacent areas. I'm hoping we will. And then, then that same principle will be used for the South Africa satellite images. The other reason I got interested in satellite is when we were supposed to go to South Africa 2 years ago. So I'm really disappointed because of COVID. And I finally realized, well, we can at least get satellite images and get going, right? Yeah. So that's the other nice thing. Or like you're saying, Shasta County, you can get the images without having to go up there. Mm-hmm. And the other thing we're hoping that would make sense to y'all is we have a couple collars that are $50 collars that I don't know if they'll hold up. So they're not agriculture grade collars. So when you see them, you may laugh. Okay. They're actually intended for dogs, but they track very well, and they're small medallions, so they could probably go on an existing collar. Yeah, I don't know if it would hold up, but that would be my concern. But we do have expertise in GPS, so on the team we have the ability to build a great collar. But I don't know. You said you also get collars from University of New Mexico and other places. Yeah, we have 4 low-tech 3000 collars here. I'm not sure where. I'll have to find them, but so I purchased them about 6 years ago, and they've been on cattle all through California and the West. So my colleague at New Mexico State, he's got about 30 of those low techs that he has bought over a lifetime, but okay. they are definitely expensive. They're about $1,700 a pop now. So, yeah. And he's the one that typically handles the data. So, because that is not my expertise. It's hard enough for me to get them on the cows. So, but if you guys have some expertise with that stuff, that would be awesome. Yeah, our approach, like what we usually try to do is use the cheapest thing we can with the assumption that it's going to get destroyed.
Yep.
And see how well it does before we spend more money. And then we tend to focus on the software and the data. And that has led us to, for example, to acquire a $30,000 radar, but we didn't start there. Our goal was to not have to buy the radar.
Right.
And so that's kind of the approach we were thinking of. The collars I have there, it's somewhere around $2 to $4 a month to have continuous tracking to a mobile phone too.
Cool.
So it uses narrowband IoT, but that's the kind of thing we're interested in. That obviously would help us. We have old satellite images, I should explain. We don't have future ones yet. But if we were to buy future ones or ones that are in the past in the future, if that makes sense, we would want to have some animals with tracking so that we could compare the tracking.
Yep.
Yeah. And so, so within our very limited budget, those dog tracking collars were the only thing we could really, justify. But my thought was, why not give them a try? If you think, it's no harm to the animal, I can show you one, but it's literally, it's really small, lightweight thing.
I would be more worried about the cows harming your collars for sure.
Well, we don't care.
Okay, you know what? I think there's a solution there.
Yeah, so we always start with expendable stuff. We start low cost, low tech, and then we find the limit, and then we figure out if we need to spend money. Kind of do the opposite sometimes of what the big government projects do. And actually, they kind of like that. So I've been invited to places like the Air Force Research Lab for that reason.
Yeah.
I had NASA tell me they thought our $30,000 radar was low cost, and they were amazed at the data we were getting out of it. And I said, well, the students tinker with it and do amazing stuff. I was like, let's just use it. And the students are like, no, let's upgrade the firmware and let's get the latest version of the software. So I think a lot of times, there's some pretty amazing things you can do with teams like this and some low cost stuff. So in the last two slides, I won't spend any time on. This is just, kind of things that we know what we're doing. Awesome. So over the last 9 years at these three universities, we've put up satellites, we've done drones. These are our latest robots over here at O'Connell that we're using for our students to learn about robotics. And, there's a lot of robotics in agriculture in the works, for better or for worse, but, it's interesting. So, we thought in general, this is an interesting way to serve the CSU mission, collaborate between two different colleges, and get an interdisciplinary group of students working together. Yeah, absolutely. Man, this is great. Thank you so much. I'm excited and I have so many ideas. What's your time like, Sam? Could we open it up maybe for a quick class discussion? I'm just curious what they think this technology could be applied to from a range standpoint. Yeah, no, I don't have class till 4, so I got plenty of time. So as long as you guys want to discuss, I am here. I will give you back the screen in case you need it. And I'm glad to do, answer questions. I'd love to hear your ideas.
Yeah, maybe that's a good place to start. So what questions do you guys have or points of interest that came up during the presentation?
I was interested in I think it was the mesh network sensors. I kind of was what do the sensors, what data does that sensor capture within a mesh network? Yeah. I know you said something about being inside, and then the perimeter catches the outside.
Yeah, that's a great question. I think the simple answer is a whole lot of things, but it could even be things you can almost imagine, instead of a collar that tracks an animal, it could be like a Fitbit for an animal.
Oh, okay. That's neat. Yeah.
I think those are out there now. So, but they're in development, early stage development, but we could probably rig one together, put some temperature monitors and things like that. So that's one answer. The other thing is, the idea of mesh is it would be useful, and I'm not saying we want to do this in phase one because there could be safety issues, but it would be nice to have some cameras inside the fence.
Yeah.
You could even put a camera on an animal, right? I'm not saying we want to do that again. I'm just pointing out, the technological possibilities. I know in Alaska that has been done with grizzly bears, and it's quite interesting.
Oh, I
So
bet.
pretty small cameras to see things from the bear's perspective, right? And then we can put microphones interior in the mesh, and that is usually fascinating because you can, with microphones, you might think like, well, the main thing you get is the animal sounds, right? But you can locate sounds just like humans can with stereo acoustics. And so the two technologies are called sound intensity probe and beamforming. But that humans do that. We do that with our brains and we don't even think about it, right? And that's the classic, I hear something over there and then you look. So of course, I'm sure animals do that. And, so you could probably learn a whole bunch of things about behavior, I'm guessing, with mesh networks.
And that's really interesting. Yeah, I think that was probably my favorite part. I like a lot of like the animal behavior and things like that. That's interesting.
Great. Thanks, Cheyenne. Any other questions or comments about the technology?
Is this how you do all the Planet Earth and then Discovery Channel?
Yeah, well, you never know. We had Obama visit our ADAC center. He came out. I think that, that's part of, if you get a grant that large, you get visited. And then we also had the, we had an Air Force general take over as the program director.
Wow.
I think the Coast Guard was like, these guys need some help with management. But I'm still friends with him. General Church Key is his name. So,
Cool.
But his last name is Key. He goes by Church. But field research is great. I love this stuff. I'm a computer scientist, so that tends to conjure up images of someone stuck in the cube. But I've worked hard to get out of my cube in my career, and I enjoy getting out there. So I've gone off track. I don't know if I answered your original question, but
That's great. So you guys, if you have other questions, pipe in whenever needed, but I have a question that I want the class to kind of think on for a minute or two and then share some responses. And I won't pick on anybody, but because you guys are pretty good about, sharing and stuff, but based on what was presented and the different technology and the different data that can be collected, how do you think, and we don't have to solve the problem right now, but what do you think this technology and methodology could help from a range management standpoint? And it doesn't have to be just here at Chico. It doesn't have to be in California or the US. It can be global.
Possibly if the cameras get good enough carrying capacity based on forage amount.
Yeah, so if we can try to figure out like density of forage and potentially like put a number on that, like this many pounds is produced per acre or per section, that could really help with carrying capacity, especially probably in like extensive rangeland situations where we can't hike to it to collect a sample, right? So, or don't have the time to hike in. So I like that suggestion, Tessa. That's a good one. Hey, what else?
I was thinking like the ecological progression.
What do you mean?
Like after a fire or
succession,
like a disaster, yeah, ecological succession or like the progress it's made or not made, like after a disaster doesn't necessarily have to be fire.
Yeah. So, Sam, we've got this theory. It's not a theory. It's actually fact at this point, I guess we'll call in range science, that after a really extreme event that takes vegetation off of the land. So basically all you're left with is the soil intact, is that the components of that ecological system will come back in a very systematic way. So the first thing to come back is annual grasses. And the second thing to come back is perennial grasses, and then shrubs, and then trees. And the length of that is where we can, help manage it a little bit. So, yeah, so that's the theory that Cheyenne is referring to. But yeah, I think, just thinking about some of that technology and even like the satellite imagery stuff, being able to see, wildlife species coming back into a burn scar, that would be pretty powerful, because I think that probably happens earlier than what the federal agencies tell us. And that is one reason that they actually, will keep, or a reason of many, that they will not let cattle come back to a permit after a certain amount of time in a burn scar. So yeah, that's a great idea. Cool. Others?
There could be wildlife and domestic animal like conflict in general. So whether it is other herbivores that are also grazers like the cattle, you can see those areas where there's a lot of crossover happening, and that again kind of goes into the carrying capacity. But we can also probably use it to observe where potential like areas where predation may happen quite a bit, and what can be done in those areas to probably like ward off the predators and protect the livestock, or anything that goes beyond that initial discovery by using this technology.
Yeah, I think, and just to, take your thought further, Raylene, we, as ranchers and folks that are around livestock, we're always worried about our predators being a threat to livestock, but there's also situations where it's the opposite, right? So where the livestock species can threaten predators, and that's where we see a lot of tension with the wolf issue. And so the reintroduction of the wolf. And so that's one thing that I was thinking, is we were talking about the technology, is like, if you can kind of look at images, and we've got some tracking data on some wolves and some tracking data on some cows, so that ground truth, or as close to ground truth as we can get, we could try to, match that up with some of the satellite imagery stuff to see if we can even, eventually pull out a wolf from, a cow, because some of those wolves can get to be pretty big. And then from that, we could, look at, habitat usage, and, and threat, times when, livestock might be threatened, or even the wolves might be threatened, that type of thing. So what other, just to, this is a related point. So what other herbivore in a range scenario could be at competition with cattle on rangeland? What do you think?
I mean, it all kind of depends on location. But elk can be very migratory, and they graze a lot, as well as browse. And bison, because they are very similar, also being bovidae. They graze, they're a similar size. There may be, herbivore competition with, the land use. And I don't know how much of that is managed with grazing permits and whatnot, but.
Yep, absolutely. And it totally location dependent. So, there's Arizona is a really good example of that, where they've got a lot of elk and a lot of cattle grazing on forested land. And those two things become conflicted really, really quickly. So we have lots of potential for deconflicting issues between domestic animals and wildlife species. So That's good. So Cheyenne put into the chat pronghorn antelope as well. Yeah, especially in areas where we don't have the dense tree population like we do here in California. So once you get out in the Great Basin and, are in kind of sagebrush country, that's what pronghorn really like, is that kind of low sage type areas.
Yeah,
So,
we actually have direct experience with that at Embry-Riddle. Pronghorn were all around the university, and they got relocated to Eastern Arizona. I don't remember all the reasons, but they were right around where my house, where I lived. I mean,
wow,
backyard. And then they had free range also just behind where I lived.
nice.
There's still our pronghorn there, but I think they took at least half the population and relocated them.
Cool. All right, so I want to make sure that we at least bring this up. And so I'm baiting you guys a little bit, but what other herbivore species is in direct competition with cattle, especially in this state, like the northeastern part of the state? Horses. Yeah. Wild
Wild
horses.
horse?
Yeah. Thanks, Kelvin. Yeah. And Alex and Luke both dropped that into the chat as well. So thank you guys. And that's where I really see like potential, benefits of using this technology is, we can do helicopter, counts, and we can try to be on the ground as much as possible on top of the Modoc Plateau. But, and so all the estimates that are of how many wild horses are actually there are just that. They're just estimates. Like we don't know. And we know that they're overestimated at this point, or not overestimated, that they're overpopulated. And so having some of this data may actually help with, anything from accurate population counts to identifying, areas that are intensely grazed that need probably to be managed at a greater degree. We talk a lot about the springs and stuff that in years of drought get really, really messed up big time by the horses, because they all come in as one herd and drink out of the same spring. And so you can have one spring supporting, 200 head of horses. And if they're all standing there and they're all eating there, that means that vegetation is disappearing and the soil is being degraded big time. And so those are just a couple of things that, as we were talking about the technology and that type of stuff, I thought that would be very, very interesting to look at. So Cheyenne, you got your hand up.
Is the technology not used because it's not widely known about yet? Or like, if they're using it for like the elephant rhino people project, how come they're not using it here for like the wild horse? I was just kind of curious about that. Is it just because it's not known, or?
I think that's more due to funding, right?
Do you want me to give my answer?
Yeah,
Yeah.
yeah.
Okay. I think it's a little bit of both of what I heard. I think cost is an issue, but that should be coming down. So one of the things our group has done is we look ahead and say, here was the cost, 5 years ago, it's here now, it's going there, right? And so if we get the technology and the methods in place ahead of that, then, we can use that better. Radar has been essentially replaced in aviation. I don't know if people knew that. I mean, you still have radar at big airports, but there's one radar in all of Arizona now, because everyone uses ADS-B now, which is an alternative technology, which is basically like tracking colors for aircraft. So just give that as an example. But when you see the technology going a certain direction, the science can be aware of that, you can imagine the things you can do in the future. Right. Start doing them now, even though they're maybe awkward and expensive. But then when the technology gets there, you're ready, right? Yeah. Instead of catching up. And so that's one thought. So the images we purchased were expensive, but we can get grants. And the other thing is the CubeSat that I showed you at the end, there's lots of CubeSat ideas for global imaging. There's also, as you're probably aware of, people like Elon Musk who just, I've met him twice and I credit students for it. You know, so I don't know if I can get another meeting with him, but I met him twice because I had students at Arizona State and Embry-Riddle entered his Hyperloop contest.
Oh.
Last time I saw him, he tried to sell me a brick.
Huh.
Not kidding. He's like, we went out and shook his hand, you know, hey, we're the Arizona team. And he's like, oh, I've got these bricks here from my boring project. Would you buy one of these? I'm like, you mean like now or just in general? So it's an interesting character, but there's things like that going on that I think, you know, technology and science, if we work together, I guess, you know, there's probably more we can do and so we did that for, you know, that was what we tried to do with the Coast Guard. So obviously the Coast Guard has amazing technology, but it's very expensive. So the same question was asked, why don't they have infrared imagers for each, you know, everyone working in the Coast Guard, right? And now you can get, you know, ones you can put on your phone and stuff like that, but they're too low resolution. But you don't need to fly out a C-130 with forward-looking infrared for every problem. So we we're willing to work with low-cost stuff like those $50 dog collars and see what they can do.
Yeah.
And then, you know, so like one of the papers we wrote, NASA said, well, you guys need a radar. So I turned it around on them. I said, where do we apply? See, so I wouldn't rule anything out, you know, right? If we get the research going, there is funding out there, and then there are ways to go lower costs and at least start working on the problems.
Cool. Wow.
But I think, you know, the other scientific answer is it is right. It is edgy, right? Like if I could show you more images of whales and caribou and, you know, detection and counting, really, I think the Oxford paper is the first one that said they gave scientific evidence that it's possible. And that was just in January.
Wow.
So it's, you know, it's pretty fresh. That's the other answer. I think it's just, it is new. I asked Worldview, they are in this to sell images. So they love it. Here's a new place to sell images, people who are, you know, doing things with animals like your range science and so forth. So obviously they like it, but they're not quite there yet. But I imagine Worldview 5, Worldview 4, by the way, is lost. They lost control of the camera. It had twice the resolution, and those are really nice looking images. But you know, there'll be a Worldview 5, or Elon Musk or someone like that or whatever will come up with things. The biggest barrier might be the fact that it's also, you know, like infrared, it comes under ITAR. So the Department of Defense has the ultimate say on what we get too.
True.
So if you have a high enough resolution infrared camera, I had to keep those locked up in my office. The university had to sign for them, all those kind of things, because some of these things in the wrong hands can be, you know, serious weapons actually.
Yeah, sure.
Or used for, I guess, you know,
Evil. Used for evil.
That's the way to put it. Yeah, that's the right. So, but they can also do amazing things like long wave infrared. I started working with, and the first camera I bought was $10,000. The most recent one was $1,500, and it's the best one.
Cool.
And that happened over the past 9 years. So, you know, I guess it's like just taking advantage of technology, you know. So we want to get in a philosophical discussion. Technology is probably creating and solving problems at the same time, right?
Yes.
Let's get on the solving side of the use of it, I guess, you know, on some of this. So the information is, I think, great that, you know, if you can collect it, then it's not always clear what you're going to do with it, but I guess that's why it's research.
Yep. Excellent. Well, this was great. I'll just open it up for any other questions or comments for a quick minute, and then we'll let you get to your class, Sam. So. All right, guys, any questions or comments?
I just
Wanted
needed
to
a
say-
clear,
Oh, sorry, go.
sorry, Cheyenne. I just need a clarification on what the main of using the satellite imagery for the elephant, rhinos, and people project was.
Yeah, I mean, so the first reason isn't a great one, which is we couldn't go and we wanted to see what we,
Okay.
but it did get us going. So we wanted to start the research. We actually have some funding at Embry-Riddle that came from Uber, and we wanted to get going. So that was the first reason. The second reason is I heard about the Oxford paper, and I think detection and counting is useful. So getting animal counts, and that's pretty hard to do over something like a game reserve, large area. And the fact that it generalizes, so you could say, why not just have humans do it? Well, if you're going to do it every day, that's where I think the automation comes in. And so that's a case of, we might be a solution looking for a problem. We know how to do that. And so I guess part of it is just the curiosity. Can we do that with other types of animals? But then also the belief that it would be useful when as the satellite images become more readily available at a lower cost, could groups like yours use that information?
Yeah.
And we should be able to geolocate them. So we should be able to detect them, count them, locate them, probably classify them in, at least by sex or, cow, bull, et cetera.
Mhm.
And that's, I don't know if we can recognize or identify them, but maybe in the future, but certainly with the ground truth. So all those were questions we wanted to answer for ERP, because basically, those were the challenges presented to us, and they were using drones and cameras and things like that. And so their question to us is, what else could we be doing?
Got it.
Yeah, and I
All
don't
right.
use satellite images at all.
Perfect. That cleared it up. Thank you.
Cheyenne, did you have a question?
Oh, no, I was just saying thank you because, there's a lot presented. I guess it was a lot to wrap your head around, but of technology and information that I've never heard of, like being used or applied. And it was kind of interesting to have a guest speaker / like lecturer, like bring that to the forefront. And I really enjoyed it.
Great.
Yeah, well, thanks for inviting me. I always enjoy it too. So
All right. So Sam, we will see you tomorrow at the beef unit, actually. So I'll just open it up for the class. I don't think we all need to show up there in an organized fashion, but also I don't think anybody's going to police us. But if you guys want to come out tomorrow, we're meeting at the beef unit at 3 and just going to talk through some strategies and maybe figure out where the cows are going to be at. That's the first thing we got to figure out. And then where we can put some of the cameras and stuff. So for at least phase 1.
okay, sounds good. And so the plan is to meet at the farm at 3. Is that right, Casey?
Yeah. Yep. And
Okay.
just right there where we met last time, you can park in that same parking lot, and we'll we've got the gator. So if we need to haul cameras and stuff out there, we've got that. It's better than, boonie hopping in a car or something like that. So
Okay.
yeah. And I think, and later on too, Sam, especially if we can get a little bit more rain and get the grass started out at our range property, I think that there's going to be some application for this out there as well. I'm excited about that aspect of it. So.
Okay.
Cool. All right. Well, thank you so much. And as far as my class, you guys know what's due on Friday, and open invitation for tomorrow. And I'll hang out for a few more minutes in case anybody's got any questions. So thank you again, Sam. We appreciate it.
Yep, you bet. Right. Well, I'll see you guys later then.
All right. Bye-bye.
Bye. Thank you.
You bet.